Hello friends, welcome back to tutorial. Our next topic is closure properties of regular languages. Suppose L1 and L2 are two regular languages. R1 is a regular expression which represents the regular language L1. R2 is a regular expression which represents the regular language L2. Then L1 union L2 will also be a regular language, and the regular expression corresponding to this language L1 union L2 will be R1 plus R2. L1 concatenation L2. L1 concatenation L2 will also be a regular language, and the regular expression corresponding to that language will be R1 R2. R1 clean closure will also be a regular language, and the regular expression corresponding to this language will be R1 clean. Now, if L1 is a regular language, then L1 complement will also be a regular language. L1 complement will be the set of all strings which are not present in set L1. L1 complement will be a regular language if there is some finite automata that will accept all strings of set L1 complement. Suppose this is a finite automata which accepts the language L1. Now we have to make a finite automata which will accept the language L1 complement. It means we have to design a finite automata which will reject all strings which are present in set L1 and will accept all strings which are not present in set L1. So this is a finite automata which accepts L1. So this finite automata will accept all strings of L1. Now we have to design a finite automata which will not accept any string which is accepted by this finite automata, and those strings which are rejected by this finite automata should be accepted by that finite automata. Now what we have to do, we will convert all final states of this automata into non-final, and non-final states of this automata into final states. Now what will happen, this new automata will accept the language which would be the complement of the language which is accepted by this automata. So it proves that L1 complement, if L1 is a regular, then L1 complement will also be a regular language, because we can design a finite automata which will accept the language L1 complement. Now next is the suppose. Now next is reverse of a string. Suppose there is a string A1, A2, A3 up to AN. Then the reverse of this string would be AN, AN minus 1, AN minus 2 up to A3, A2, A1. So if there is a string ABC, then its reverse will be CBA. Suppose L is a regular language, then LR is a set of all reversed strings of set L. Now, if L is a regular language, right, then LR will also be a regular language. What LR represents? LR represents set of all reversed strings of set L. So if L is a regular, LR will also be a regular language. Now we have to prove that LR is also a regular language. It means there should be some finite automata which will accept the strings of this set LR. Now suppose this automata A accepts the strings of language L. Now we can design an automata for language L, for set LR from this automata A. What we have to do? Reverse the direction of all edges of transition diagram of finite automata A. Right? Second, make the initial state of A final state. Here Q0 is the initial state, we have made it final state, and final states non-final. So these are the final states of A and we have made them non-final. Now make a new initial state with empty transitions to final state of A. Here we have made a new initial state Q0 dash, and there are empty transition from this state to the final states of finite automata A, which accepts the language L. Now this will accept the language LR. If there is a string accepted by this automata A, then reverse of that string will be accepted by this automata. So it means if L is a regular language, LR will also be a regular language. Now, if L1 and L2 are two regular languages, then L1 intersection L2 will also be a regular language. By De Morgan's theorem, L1 intersection L2 will be the complement of the union of L1 complement and L2 complement. So here L1 complement, if L1 and L2 are regular, L1 complement will also be a regular language, L2 will also be a regular language, and their union will also be a regular language, and the complement of union of a regular language will also be a regular. Now L1 minus L2 will also be a regular language. This is equals to L1 intersection L2 complement. L1 intersection L2 complement. L2 complement will also be a regular language because L2 is a regular language, and the intersection of these two regular languages will also be a regular language. Thank you very much.